Alright, so these are the solutions to the projectile motion notebook problems. They were due Friday on the 5th, and I ended up collecting those and going to go over them this last week before midterms. So PC21, that comes from the physics classroom numbering, basically says we've got someone throwing a rock along the lakes, trying to skip it. Requires a horizontal velocity of 26 meters per second, height of 0.45 meters above the surface. So it's split up into thinking about vertical and horizontal components of this problem. So if it's asking to take how much time it takes the water to fall to the surface, that's normally a vertical thinking thing. So you need to use a vertical equation, vertical information. So we've got our delta y equals 1/2 at squared. I would write down the information that you know, and you should know gravity's acceleration, whether or not that's stated. And so it ends up mathematically coming out to 0.303 seconds or 0.30 seconds. Again, you've got to show me these steps on any test or quiz. General formula first, plug in numbers, answer with units. When you're figuring out how far from the edge of the water the rock travels, that's a horizontal motion problem. And we only have one formula for that goes with projectiles. So that's a rearrangement of our average velocity formula. So that's horizontal velocity times time. We just figured out the time. Horizontal velocity is given, so that's around 7.9 meters. For PC22, it's almost exactly the same thing. So the numbers are different. So we've got a horizontal motion of 4.6 meters per second, a vertical distance of 2.3 meters. Figure out the time first. Use the time and the horizontal speed to figure out the distance that the person goes sideways or horizontally before they hit the water. And then a couple things are important. Are here down when we're thinking about horizontal vertical speeds. The horizontal speed at which she enters the water is 4.6 meters per second. Why? Because for projectiles, horizontal speed is constant. Does not change. Gravity doesn't act horizontally or in any way to change the horizontal motion. For part D, what's the vertical speed with which she enters the water? Well, that one we would use a vertical formula for. So that's VI plus A times T, but the vertical velocity started at 0 meters per second. So essentially that's A times T, or about 6.7 meters per second. You could also use this formula, which is another vertical formula you could use. So either way, those should give you the same answer. PC26, looking at this again, first thing, a lot of information there. You're solving to find the time to fall. Second thing, you're going to find the horizontal displacement. So again, that looks like parts A and B of the previous two problems. And then the vertical speed of the fry upon striking the floor. That's just like part D of this problem. You can either use this vertical formula, acceleration times time, or this one, Vf squared equals 2a times delta y. In both these cases, the initial velocity vertically is 0 because we're dealing with horizontally launched projectiles. So this is only 4.7 meters per second. For PC24, I think the answer initially I gave you in class was wrong because I plugged answers in wrong. I was doing it quickly. And so this is a horizontal distance. This is a vertical distance. I think I plugged it in wrong. So I have 45.1 equals 1/2 at squared. Come out with 3.0 seconds. That's supposed to be a dot there that didn't show up very well when I scanned it. And then to figure out the vertical speed, the distance off the edge of a cliff is 17.8 meters, and you're trying to figure out the speed with which they're running off the cliff, so this is slightly different. I know the horizontal distance, I know the time, so that's just dividing those two. So that's 5.9 meters per second is the speed at which the person ran. So that's a little different than these ones, where you're asked to see how far they go. Here you're given how far they go, and you're asked to find the horizontal speed with which they run off the cliff. So hopefully those help, and you're ready for your test.